Okay, now that we have talked about, when I introduced the topic, I showed you a range of sprayers which are used to deliver the pesticide to its target. Then after that, we tried to understand about the droplets. There's a bit of physics in it, but we just have to mention some of these things so that we really appreciate that droplets, their nature, can affect the efficiency of the use of the pesticide or its efficacy. So now we want to zero in on the part which really creates these droplets. Now that we know that the droplet size can vary, what makes them variable? It could be the nature of the nozzle which creates these droplets, and there are various nozzles which have been designed to deliver different types of droplets so that they can be targeted to the pest. So a nozzle is any device through which a liquid can emerge. The liquid then breaks into droplets. So let us look at the production of droplets. There are certain nozzles which are known as hydraulic energy nozzles. Within the hydraulic energy nozzles, a liquid is forced under pressure through a small opening orifice. So you force a liquid through a small opening. The pressure required is around 14 pounds per square inch, which is an old term, but we can say it is equivalent to between 2 and 3 bars. So you have a sheet of liquid that breaks into droplets. So the components of the hydraulic nozzle, it has 3 things. It has got the body, the filter, and the tip. The tip has got a small opening which creates those droplets. And this is what it looks like. So you have got the top blue part there with that arrow, the black arrow going downwards. That is the direction of the flow of the liquid. Then the liquid is going to be restricted via a small opening, and it breaks into droplets. So this is the hydraulic nozzle. Hydraulic nozzle. Number 2, we have got the impact nozzle. The impact nozzle operates at low pressure. This can be used for herbicides, them where there are problems with the blockages. If there are problems with the blockages, which can be serious when you are spraying herbicides. If you also need a wide area to spray, which is a wide swath, you use an impact nozzle. Now, if you look at the tip of the nozzle, for example, it has got 8003, meaning the spray angle is 80 degrees. 0.3, this one is in gallons per minute, which is 1.14 liters per minute. That is the information which is being carried. Now, in many countries, the preferred angle of the spray is 100. So this is a simple diagram of a flat jet nozzle or an impact nozzle. You have the liquid shown in brown hitting a hard surface, and it breaks into droplets. So this is what a flat jet nozzle looks like, and we use this nozzle for applying herbicides. That blue part there is the filter. The other nozzles which are common are known as funny nozzles. Now, in this previous nozzle, please note that the liquid is forced to hit something which is hard, and it breaks. That's how the droplets are formed. In the first one, the hydraulic one, the liquid is forced through a small opening, that's also creating droplets. And if we could move to the third one, which is a bit complicated, funny nozzles. In a funny nozzle, you've got two jets of liquid which strike each other at an angle greater than 90. So you've got two jets of liquid which hit each other, then it breaks into droplets. First, a thin sheet of liquid is produced. This is ideal for spraying flat surfaces, on soil surfaces and walls. We can put it on the conventional tractors and aerial spray boom. So two jets of liquid strike each other, form a sheet and break into droplets. That's how the droplets are formed. So these are the common funny nozzles which we use. That's what they look like. For flat funny nozzles for the application of herbicides. Again, flat funny nozzle. The spray has got this fan-shaped structure. Again, this is the type of nozzle, and towards the target, you've got a wider area. It starts with a small angle then it widens. That was the flat fan nozzle. Then there's an even spray fan. Some of these names can be confusing. Even spray fan. This is good for bend application of the herbicides. If you have got a nozzle like that, it's now different. Look at this one. Which we call the flat fan nozzle. It forms more or less like a triangle. That is the shape of the spray. Even spray fan, good for bend application of the herbicides. This is more or less like a rectangle. That's the difference in the spray pattern. So even spray flat fan at the edges, it's almost like a rectangle when it hits the ground. Those were for herbicides, those two types of nozzles. Actually, I have described the three types for the herbicides. The first one was for insects. Cone nozzles, liquid is forced through a swirl plate. So there's a plate which probably rotates with some holes on the plates. It is these plates which actually produce a thin sheet of liquid which breaks into droplets. It is used widely to spray foliage, for bigger coverage. Droplet approach the leaves from more directions compared to the flat fan. Because for this one you are targeting insects, so you want to increase the probability of hitting an insect. This is what they look like, hollow cone nozzle. Although there's a small nozzle, inside there are some plates, which is the mechanism for generating droplets. This one is the plastic hollow cone. Okay, let me admit somebody who is late for coming. He is in. Let me go back. Right. The other nozzle is known as the plain jet or solid stream nozzle. It is similar to cone nozzle but without a swirl chamber. This is for spot treatment of weeds, young shrubs or trees with herbicides. It's used to apply molluscicides to control vectors of schistosomiasis to ponds and canals. So you have that is the sort of nozzle, that is where the liquid comes through. And please remember it's the plain jet or a solid stream nozzle. Plain jet or solid stream nozzle. This is it. At the end you get droplets being formed. So this is what it looks like. It's just like a pipe where fluid is fed into it, and at the other end you have droplets being formed. The difference is with the first one is that probably the nozzle at the end is a bit wider. The wall is a bit wider, maybe. Then we've got what are known as foam and air-operated nozzle. So you need to mix air and the spray solution so that you produce foam. So air is mixed with the spray before it is allowed through an orifice. So you mix air and the liquid. Foam is produced. You get fan and cone-shaped patterns. This can be used for swath marking. If you want to see where you are spraying, you can use this one. So this is what it looks like. It can mix air and the spray, and it forms that sort of foam or foam. We move on to the microfoil nozzle. This is the nozzles which are used on an aircraft. You know, we said in aircraft, initially I showed you an aircraft spray. The type of nozzle fitted to that aircraft, particularly the helicopter, is a sort of a needle. It can produce large droplets with no drift. Two sizes of needles, 0.33 and 0.7 millimeter diameter. So probably this could be the part of the wing where liquid is fed into that wide area. At the end you have got needles which are fitted, and at the bottom we have got a sample of it where water enters into that fairly thick area, ending with a narrow tip, and that will create droplets. So this is the microfoil nozzle. You have got an airstream there. At the tip, that's where you get your droplets being formed. Again, that's what it may look like, where you have a lot of needles which are discharging droplets. This is part of the aeroplane which is actually spraying. So this is a picture of that kind of nozzle. It may look like a plug, but the black end there is that is where you get your droplets. So please note the microfoil nozzle. That is the diagram, and this is the picture of the microfoil nozzle which can be fitted on an aircraft system. which sprays. We have got gaseous energy nozzles, twin fluid. I don't know, you could have seen these nozzles, gaseous energy nozzles, where you pump a stream of air. When it hits at the tip, liquid is, moves through a small pipe, and the way air and the liquid meets, droplets are formed. Sometimes this can be used to apply insecticides in a house or in gardens on a small scale. And please remember, it's gaseous energy, the GE nozzles, gaseous energy nozzles, or twin fluid. Then we have got the centrifugal energy nozzles, spinning disc. I think these are commonly used the way cotton is being grown. They sometimes use these spinning discs, because carrying, heavy tanks containing water or pesticide may not be comfortable. So you need a small tank so that you can freely move. And you require a spinning disc or centrifugal energy nozzles. So the liquid is fed into a rotating surface. This is less liable to clogging. So these are the spinning discs which apply insecticides in this country, particularly in cotton. Well, it's very rare to use this for herbicides, but you can also use them for herbicides. They are very light. The other one is the kinetic energy nozzle. Liquid is fed by gravity through a small hole. I don't think you'll forget this one. This is the watering can. You have a rose which is attached to the watering can. If you have used it, it's the kinetic energy nozzle, because it also forms droplets. But normally we don't use this for pesticide application, but we can. So this is the watering can, but this one is the special one, with a very thin end. A mist blower. This one creates a mist. You have a pipe there which probably delivers the pesticide, which is going to be mixed with smoke. So this is the mist blower. It has got an exhaust pipe. So what comes out of the exhaust pipe will be mixed with the pesticide. It's known as the thermal energy spray nozzle. You can see at the end it's quite a wide nozzle. It's just like a pipe. It's like an exhaust pipe, in fact. It is used to produce fogs, stream of hot gas which comes from the engine, This is for disinfection, hot gas obtained from exhaust of thermal combustion or small jet engine. You can see the mist blower producing that smoke. It's like an exhaust pipe. Again, because you are targeting something in trees or plantation crops, so you need mist blowers so that the smoke carrying the pesticide can reach the top of the trees. This one you may not forget it because you may use this every day. Pressure pack nozzles which deliver aerosol or liquid gas. We may buy these in shops. When we want to kill insects, we use these. That one. So please remember, pressure pack nozzles which produces aerosol and liquid gas. Now, before we spray, we may do those nozzle checks, especially under field conditions. Calibration of flow rate. We can also check what is known as the spray pattern. We use the special equipment known as the patinator. I think it's the weed research team. They have a patinator which checks these nozzles. We also check for nozzle erosion damage, because when we do calibration, if the nozzle starts discharging more fluid, maybe we stop using it. I think this is it for nozzles. I'll stop.